Okay, students, today we are continuing our study of quadrilaterals with trapezoids and kites. These are two shapes that have been introduced to you before, way back in elementary school, and you did a little bit of work with it in middle school, but we're just going to continue the steps here. We're going to start with vocabulary. We have a trapezoid first. A trapezoid is a quadrilateral. With one pair of parallel sides. Okay, now if you look at a picture of them, this is the traditional type where we have a short side on top, a long side on bottom, and then two sides leaning in. It kind of looks like it could be a triangle, but the top's been cut off. Now, this side and this side are parallel, but this side and this side are not. Now here's another trapezoid, and this is a non-traditional shape, and I'm going to have it tumped over on its side here. So this is also a trapezoid. Okay, so this side here and this side here would be the two parallel sides, and these are the non-parallel sides. Next, we have the bases of a trapezoid. So, the bases of the trapezoid refer to the parallel sides. Of a trapezoid. Okay, so if I draw this non-traditional one, where this side is parallel to this side, that is a base and that is the base. The two parallel sides are the ones that are bases. A trapezoid doesn't have to be sitting on the base like this one here. It could be tumped over on its side like this. Alright? Base angles of a trapezoid. Each trapezoid has two pair of base angles. And each pair shares a base as a side. Alright, so I'm going to draw a triangle, not triangle, a trapezoid here. Still non-traditional, but I'm going to have it tumped over, sitting on its base, where this is parallel to this. Okay, so this angle here that I'm using an arc mark, a single arc mark, and this one here, these are considered to be base angles. Notice how this angle right here is made by this side of the trapezoid and this base. And this one over here is this side and this base that make the angle. So they're sharing this base right here. And again, it has two pair of sides. So this side right here, or this angle right here, and this angle right here, that's another set of base angles sharing this base right here. Now, this is very important, so make sure you write this down. Okay, so the arc marks indicate the base angles and are not indicating congruency. It's not trying to say that these two are congruent, because clearly you can see that they are not. Now, could they be? Absolutely. But they don't always have to be. So that would be, if you had a sometimes, always, never question, that would be sometimes. All right, next, legs of a trapezoid. The legs are the non-parallel sides of a trapezoid. Okay, so for this one, I'm just going to draw a more traditional, where that is a base and that's a base. So that would be a leg, and that would be the leg. Those would be the legs right there. I'm going to highlight those in yellow. The legs are these here. Okay, and this one up here, the bases, that would be the parallel sides, this one and this one. Okay, there you go. Next, mid-segment of a trapezoid. We had a mid-segment of a triangle before, and it is very similar. It is a segment that connects the two, or the midpoints, of each leg. Okay, so here I'm going to draw my trapezoid, and I'm going to find the midpoint of this one. You could fold your paper and find the midpoint. It's about right here. That's a midpoint. And then this one, if you fold it, it's about right there. That's another midpoint. I'm going to call that one N. So I know that this segment and this segment are congruent. So these are hash marks. This is a double hash mark, because those are. But clearly that's not congruent to that. They have. Now, could they be? Yes, but they don't have to be. So that's another sometimes, always, never. It would be sometimes they are congruent, but not always. Okay, so this side would have to be congruent to this side in order for those pieces to be congruent. Next, we have isosceles trapezoid. Just as a triangle, when it's isosceles, it has two sides that are congruent, so does a trapezoid. So a isosceles trapezoid is a trapezoid with congruent legs. Okay, so when you draw this, and you know that that's parallel to that, these are congruent. That's a isosceles trapezoid. All right, finally, our last vocab word today is kite, and a kite is a quadrilateral. With two pair of consecutive congruent sides. But opposite sides are not congruent. Okay. So consecutive means next to each other, side by side. So if I'm going to draw a quadrilateral, here's one. And then the very next side that I draw has to be the same length. So I'm going to draw another length over here, the same length. So that length and that length are congruent. But the side opposite that I'm about to draw cannot be, that one cannot be the same length as this one, and that cannot be the same length as that one. So I'm going to make these one hash mark, and these are double hash marks over here because those are longer. Okay, so that's a kite. Alright, now we have some theorems. These are our trapezoid theorems. And it says if a trapezoid is isosceles, then each pair of base angles is congruent. Now, remember when I said sometimes up here how they're not congruent? Well, if it's an isosceles triangle where you have two parallel bases and the legs are congruent, then the base angles are going to be congruent. Let's draw that here. If trapezoid ABCD is isosceles, then, so let's label it A, B, C, D, and we're going to show that this is a trapezoid. This is how it will look. An isosceles trapezoid will look just like that. Okay, so if this is happening, then we know that angle A is congruent to angle D, and angle B is congruent to angle C. Okay, next, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. Okay, so over here, if we know that angle A is congruent to angle D, and we don't need both of them, we just need one pair. So you could have this and then in parentheses, or you could have angle B congruent to angle C. Either one, but not both. If you have a set that are congruent, then the trapezoid ABCD is isosceles. So if you see this AB, CD, and you know it's a trapezoid because you see the parallel marks, but you don't know that these sides are congruent. If you have that a set of base angles are congruent, then you know that the two sides opposite them are congruent. Okay? Now, the next one says a trapezoid is isosceles if and only if, okay, there's that word again, if and only if, that means it goes both directions. If and only if its diagonals are congruent. Okay, so trapezoid ABCD is isosceles if and only if, so I need to label it, A, B, C, D. I know that it's isosceles. Okay, the only thing that's marked is this. If and only if you have two diagonals and you know that they're both congruent. So, if and only if, I'm going to draw this over here, AC is congruent to BD. Okay. Notice how these legs are not marked, but if you are told that AC and BD are congruent, then you know that that's isosceles. Or if you have isosceles, you have it marked with these two hash marks here, then you know that these are congruent. Remember, it goes both directions. Alright, finally for the trapezoid theorems, we have the midpoint of a trapezoid theorem. Now remember that these up here do not have special names, so you're not able to call it anything. You'll have to memorize it and write it all out. But here, you can refer to this as the midpoint of a trapezoid theorem. So, and you know what? That's a typo. This is not supposed to be midpoint. It's supposed to be mid-segment. Mid-segment. Okay. All right. The mid-segment of a trapezoid is parallel to each base. All right. Now let's talk about a mid-segment. Remember, a mid-segment that was up here, it says that it's a segment that connects the two midpoints. So you find the midpoint of this side, and you find the midpoint of this side, and this segment here that connects them, what this is saying is that we know that this is going to be parallel to the top base and parallel to the bottom base. And its length is half of the sum of the lengths of the bases. In other words, it's the average of the two bases. So you add them together and divide by 2. All right, so let's label this FMN. So here's the first midpoint, here's the second one, is a midsegment. Then what we know is, remember this is A, B, C, and D. We know that this top base BC is parallel to MN, which is also parallel to AD. All three are parallel. And we also know that MN is the average of the two bases. So it's going to equal BC plus AD divided by 2. All right. So now let's practice. Oh, we have just a few more theorems, 2 more, and these are about kites. All right, so I have, the first one says, if a quadrilateral is a kite, then its diagonals are perpendicular Okay, if a quadrilateral ABCD is a kite, so here's A, B, C, and D, then I know that the diagonals, so here's a diagonal here, and here's a diagonal here. So if this is a kite, and to know that it's a kite, you have to show that this side is congruent to this side, this one is congruent to this one. So if that's true, then what we know is that these two diagonals are perpendicular. Then we say AC is perpendicular to BD. Alright, now the last theorem for today, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Now take a look at this kite. Look how little this guy is over here. And then look at this one. These are opposite angles. Are those congruent? Absolutely not. But these two, those are the ones that are congruent. So, what this is saying, if quadrilateral ABCD, A, B, C, D, is a kite, then we're going to have these marked here. That's going to be congruent to that. This one's congruent to this one. Okay, so if that's true, then we know that this angle here between the short side and the long side, those two angles are going to be congruent. So angle ABC is going to be congruent to angle ADC. All right. Now finally we have some examples. For all these examples here that you see, we're going to use this information right here. It says that HJKL is an isosceles trapezoid. So we have H, J, K, and L. So it's going around to name it like this. Is a trapezoid with bases HJ. HJ is a base. So it's going to be the parallel side, and LK. That's a base. And this one is a mid-segment. Okay, so it says median, but it's a mid-segment because we should redo this. Mid-segment. RS. Okay, so that's saying that this is a midpoint and this is a midpoint. So right now we know that this is congruent to this. And we also know that this segment right here is congruent to this segment because we have an isosceles trapezoid. So since these legs are the exact same, their midpoints are in the same place. So the distance from the end point to the midpoint is going to be the same here, 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 and here. All right. Now let's take a look at this. Example 1. It's asking me to find the length of RS. And remember, RS, that's going to be the average of the two bases. So I know that RS is going to equal LK plus HJ divided by 2. So RS is going to equal, plug that in, what you know, 30 plus 42 divided by 2. Okay, so that gives me 72 divided by 2. So I know that RS is equal to 36. All right, there's my first one. This one is similar but not quite the same. Here I'm looking for this side down here, not the mid-segment. So, but I still know the same thing. I know that RS is going to equal LK plus HJ divided by 2. So I'm going to start there and plug in the information that I know. All right, right here. RS is going to be 17. That's going to be equal to LK, which I don't know, plus 14 divided by 2. Okay, now remember, anytime you have a fraction on one side and a whole number on the other, you can put it over 1 and cross multiply. So I know that 34 is equal to LK plus 14. Now I just subtract 14 from both sides, and I get 20 equals LK. Alright, this one here is just a bit more challenging, but we're just going to start off the same way. We're going to start off with RS is equal to, remember it's the two bases, LK plus HJ divided by 2. Alright, so here they gave me an algebraic expression. So I'm going to put x plus 5 where the RS should be. And then here they're telling me that this whole thing added together is that algebraic expression. So that's going to be 4x plus 6 over 2. And again, since I have a fraction over here and not over here, I can put this over 1, and now I cross multiply. So that's going to be 2 times the entire expression is equal to 4x plus 6. Distribute, you get 2x plus 10 equals 4x plus 6, and now it's just algebra. Combine like terms and solve for x. Subtract 2x, I get 10 equals 2x plus 6. Subtract 6, I get 4 equals 2x. Divide by 2, I get x equaling 2. But that's not what they asked me for. They asked me to find RS. And remember that RS is this up here. So plug in what you know. RS is equal to 2 plus 5. So we know that RS is equal to 7. And you can always double check and plug in here, the 2 here, and make sure that 7 RS is the average of those two. Okay, next. JRS. JRS happens to be that angle right there, and I'm going to highlight this in blue. This angle right here. JRS. We know that that's 66 degrees. They want me to find JKL. JKL, which is this angle down here. I'm going to highlight that in yellow. Wait, RKL, I'm sorry, RKL, yes, right here. RKL is that angle right there. Well, I'm going to trace this down here, just redraw it for you. Here's my trapezoid. This is J, this is K, this is R, this is S, this is H, and this is L. And remember, we know that since this is a trapezoid, we know that this side's parallel to this side. Now, I'm going to extend these out a little bit, and so that they look like lines cut by a transversal. When you have two lines cut by a transversal, you know that this angle here and this angle here are congruent because those are corresponding angles. Okay, so we know that angle JRS is congruent to angle RKL. So if this one's 66, we know that one has to be 66. So M, the measure of RKL, is equal to 66 degrees. Okay, one more page. I'm going to work the first two of this page for you, and then you're going to do the last two all by yourself. Okay, so here I've got use the isosceles trapezoid ABCD to answer the following questions. All I know is that this is a trapezoid, and that this right here is a mid-segment. It's an isosceles trapezoid, so I know that these are congruent, and these are midpoints. Okay, so first, I'm going to look at this one. AX. AX is 4. They want me to find CD, which is over here, this entire side. Well, what I know is that AB is equal to CD. So if I can find AB, then I know what CD is. Well, since that is congruent to that, I know that AB is just equal to 2 times AX. So plug that in here, which is 4. So I know that AB equals 8. So since AB equals 8, I know that CD is equal to 8. Alright, the next one. Okay, so I'm going to redraw this down here without the mid segment. And this is going to be A, B, C, D. Measure of angle ABC, ABC, this angle right here, is going to be, this angle right here, is 110 degrees. Okay, now remember, since this is a trapezoid, I know that the base angles are congruent. So I know this one here and this one here, those are congruent. It's an isosceles trapezoid, so they're congruent. Okay, this is also a quadrilateral. And remember, a quadrilateral has 4 sides. So if I want to find out how many degrees all of these in here add up to be, then what I do is I say 4 minus 2, remember n minus 2 times 180, it would equal my sum. Well, 4 minus 2 is 2, so 2 times 180, that's 360. Remember, a quadrilateral, all of them add up to be 360. So if this is 110, and this is 110, and then we know that these right here, those two are congruent, and those are x. Okay, so since I have it all labeled, I know that that's going to be 2x plus 110 plus 110 is 220. And I know that that's supposed to equal the sum, which is 360. Okay, now it's just algebra. Subtract 220 from both sides. I get 2x on the left equaling 140 on the right. That means that x is equal to 70. But they want me to find the measure of BAD. BAD, is that what it is? Okay, so there's nothing I need to do here, so I know that the measure of angle BAD equals 70 degrees. Make sure you label it. Alright folks, you're going to do 7, 8, 9, and 10 by yourself. Make sure you bring these to class with you next class period so you can get full credit for your notes. Make sure you show all work.